Greetings and welcome to this module on software review. I'm super excited about this module. I think that learning how to do software review efficiently and effectively is really one of the most important things you can ever do as a software developer. You might think that actually learning how to write code is the best thing, the most important thing you ever do in software development, but I think in some ways the ability to read other people's code and understand what it does do and what it fails to do is maybe even more important than writing code yourself. Think about that for a second. Because really, if you can do that, then you can contribute to the organization in ways far beyond your own ability to write your own code. Okay? And also it just demonstrates an ability to collaborate in a group, an ability to see things that other people can't see, and in general make yourself useful in a really profound way. So I think this might be one of the most, if not the most important modules that you'll learn about this semester in software engineering. The objectives for this module, of course, understand why we want to do technical review and understand what some of the best practices are, and then I'm going to present to you very simple guidelines or a very simple approach for software review in this class, which nonetheless will be extremely hard for you to implement effectively and efficiently. Okay, so what do I mean by optimal review? Optimal review to me is one that finds all the important defects, provides everyone with deep insight into the document under review, could be code, could be a design document. It enables the author to actually make the document better, and it does all of this in an efficient way. Minimal time spent preparing, minimal time spent meeting, minimal time out of everybody's life to do it. Okay, so we want optimal quality improvement, optimal knowledge acquisition, and all at the lowest possible cost. Okay, and then I put at the bottom, normally you can't achieve an optimal review. You're either going to get good quality improvement but not much knowledge acquisition, or you'll get something that's very costly but gets you both quality and knowledge acquisition, or you'll get something that's low cost but sacrifices one of the other two. Okay. Historically, review methods come in three different flavors: walkthroughs, technical reviews, and inspections. And walkthroughs are the least complicated and in some sense least efficient method of software review. Basically it's, you've got some code, you walk into somebody else's cubicle, you show them the code, you have a conversation about it, you get some insight, or you do it in your chat window or whatever, Google Hangout, and you're done. Okay, so there's not that much preparation, there's no checklists, there's no formal procedure, but it is very lightweight, there's not a lot of investment in it, and so in some cases, that's the best way to go, to have a walkthrough. A slightly more formalized process is called the technical review, and there the idea is that you're going to implement kind of a minimum of process. You'll have some procedure, you'll probably have some kind of checklist, and you'll probably have a preparation stage followed by an actual review stage followed by some kind of meeting to talk over the results. And this additional process lowers the risk that the event won't be a complete waste of time, which could happen with a walkthrough. You give it to somebody, they look at it, they go, I don't know, it seems okay to me. Okay, the highest cost approach, called inspection, is one that was implemented or designed by this guy Michael Fagan at IBM in the 70s, and he was interested in a way to not only be very specific about the procedures people went through, but also provide a way to measure the effectiveness and then optimize that process over time. So it's a fairly high cost way, very structured, very rigid, but appropriate in places where the cost of errors is substantial, like space shuttle software or medical software and so forth. So places like NASA or medical instrumentation libraries, they may use something like inspection. We won't in this class. Okay, so looking at my definition of optimality for software review, and we look at these three methods, walkthroughs, as I said before, very low cost, but it's unclear whether or not you're going to get much knowledge transfer or quality improvement. Technical reviews add a little bit of overhead because you've got to think through the procedure a little bit more, and there's some more kind of commitments amongst the people engaged in the process. But you're pretty much guaranteed to at least get some knowledge transfer and some quality improvement. The cost of inspection is much higher, not necessarily optimal. So in inspection you may spend a lot more than you actually could at an optimal rate, but you have the highest probability of getting decent knowledge transfer and quality improvement out of it. Okay, so why we're going to spend a lot of time in this class in testing, and the question might occur to you, as it often occurs to people, is why bother to do reviews when we have tests? And the reason being is because the reviews can apply to documents prior to code. That is kind of the essential thing that reviews can do, or one of the two essential things that reviews can do. So you can see this top little diagram. We can have a review of our requirements, we can have a review of our design, and we can have a review of our code. I guess we could also have a review of our tests, but I don't show it here. And each time, the effect of that is to reduce the variability and perhaps the overall length of that particular stage of development. Okay? So what happens is that if you don't have any reviews, then your coding and testing phases could be much, much more lengthy than they would otherwise be, because you'll be trying to repair problems that you injected during the requirements and design phase that you didn't have reviews to get rid of. Okay, so that's one of the important things. The other thing is that if you don't bother to implement a requirement, if you forget to implement a requirement, no amount of testing is going to discover that the code just doesn't have some set of functionality, because the tests are generally written against the code. Okay, so reviews are very good at discovering things. Maybe the customer, uncovering customer requirements that otherwise would have been completely missing until delivery of the code. Okay, and then finally, reviews are quite good at teaching people about how the code works and familiarizing them with them. Testing is fairly good at that too, but reviews enable people to interact with each other as well as with the code in a way that tests don't necessarily do. There's a lot of research in the 80s and 90s around software review. There's a lot of published studies that show that software reviews can save a bundle of money, particularly because of the fact that if you discover errors in your upstream documents like requirements and design, typically those errors are fairly cheap to remove during that particular phase of development. On the other hand, once you have implemented and fielded the software, if you discover a design defect at that point or a requirements defect at that point, then it's much more costly to get at it. This slide just shows you that there's been a lot of different development of review methods over the past 20, 30 years, and you can look at the literature if you get interested. I particularly think that active design reviews are very interesting as an alternative to the more standard code inspections. So I'll point that one out. I think it's important for everybody to understand the kind of the granddaddy of all software review methods called inspection, which was done by Michael Fagan, as well as to help you understand the level of formality that's possible and a level of formality we probably won't do in this class, but depending on the organization that you go to work for, if it's life-critical software, if it's missiles or X-ray machines or something, then at least you'll know in the back of your mind that there are some very formal processes which are pretty good at finding errors. So we've got these different phases, and I'll go through each of them in turn. There's a planning phase where the manager of the review gathers together the work product, whatever checklists are going to be provided, determines the team, determines the dates for the meetings. Then the review moderator calls a meeting that's called the orientation session, where the author talks about the code to be reviewed. The reviewers obtain the materials that they want to that they're supposed to look at. The goals for the preparation phase are established, and and the team's, the actual review starts. During the preparation phase, reviewers work independently to find the maximum number of non-minor issues by looking at the review artifacts. And this typically involves a classification of each issue that they discover as being either critical, severe, moderate, or minor. There can be many other different ways that you classify it, but this is kind of the most common way. Minor defects or minor issues are not even recorded. So if you discover an issue but you think it's minor, then you don't even bother with it because it's not worth the time in the process to deal with. Then you have a review meeting, and the goal there is to bring together all of the issues that each person independently came up with and discuss those issues. And oftentimes new issues will come out of that, or people will discover that what they thought was an issue isn't actually an issue because they learned something new about the software. So there's a lot of knowledge acquisition and knowledge transfer that occurs during the review meeting, as well as the consolidation of a set of a listing of the non-minor issues. Then there's the rework phase, in which point the author goes back and looks again at each issue, looks at the code, tries to figure out whether or not it's a defect, and if so, it makes the change necessary. The author will then record exactly what they did, and then the review moderator now has the responsibility to go back and make sure that for all of the issues that were discovered during the review process, that the author has actually dealt with it one way or the other. Okay, that's a very complicated process. You've got different, there's other roles, like there's the scribe of the meeting, and there's a lot of things going on in inspection. And as you can see, it's very formal, works good when there's a critical need to take a highly structured approach to trying to eliminate as many errors as possible. In our class, I haven't found it to be that great to use that structured of a review process. And so I like to kind of downshift to the technical review process and think of it this way, that what we want from our technical reviews is a way to obtain useful feedback about classmates from your software system, to learn how to critically read and evaluate code that's written by somebody else, and very importantly, figure out how to distinguish between feedback that's just minor. I don't like the way you wrote this documentation string or something like that, versus the kind of high impact error with respect to the logic or the functionality that the author might not have picked up on. Okay, and then also hopefully you'll discover that by doing reviews, you actually, and looking at other people's code, you pick up a lot of things that you wouldn't have thought for yourself, or at least you'll learn them more quickly than you would have without the opportunity to read other people's code. So what we want to do, practice in this class, is what I call a checklist-based technical review. So for each review that we do, either I or you folks will establish some kind of checklist about what is supposed to be accomplished by the review and what the reviewer is actually supposed to look at. Okay, and that's a really good way of focusing the attention. It has the cost that sometimes, if you don't design the checklist right, important issues will be completely overlooked by the reviewers because you'll be focusing them in other areas. That's the cost of the checklist. The benefit of it is that you prevent reviewers from going off in some direction that might not be worthwhile. It's always important to actually write down all of the issues that were raised, not simply verbally communicate them to the author so that they're actually recorded. And that there's a process whereby you go over these comments with the author to make sure the reviewer and the author get together and go over the comments in person in order to make sure that there's good communication of what the issue actually consists of. And this lowers the burden on the reviewer to write an exhaustive comment that stands alone and is self-sufficient for communicating to the author what they need to do. So the comment can be, it should be pretty specific and pretty clear, but you know that you'll always be able to go to the author and talk more about it. Okay, so what I want you to take away from this, whenever you're doing a review, either this semester or in any other context, you want to ask yourself, is my review process actually revealing problems? Is my review process actually increasing understanding of the artifact? And is it doing both of these things, revealing problem and increasing understanding, efficiently, with a minimal amount of time for both the author the reviewers. And if it's not, then think about ways to change the process to make it more make it more efficient, or solve whatever the lackings are of it. I think that software review is the art of collaboration at the end of the day, okay? And that in agile methods that we'll talk about later in the semester, they claim that there's never any need to do a formal technical review or inspection or even walkthrough, because in some agile techniques like extreme programming, there's always two people working on the code simultaneously, and they're always talking back and forth. So the review is happening in parallel with actual code production. And there's an interesting question about whether that's more efficient or less efficient than independent software development coupled with some kind of technical review process. But we'll get to that later. Hope you've enjoyed this brief introduction to software review. Go take a look at the readings, and we'll have a chance to practice it soon.